what we call the umbo. Kind of like Dumbo with the big ears, but umbo, just U-M-B-O. So number 7. So the malleus is connected directly to the umbo of the tympanic membrane. So every time the tympanic membrane moves, the malleus moves. These are synovial joints. The malleus moves, vibrates the incus. The incus vibrates the stapes. So these, as they vibrate from one bone to the next, they're amplifying that waveform, and then the stapes is going to push on what we call this inner ear and create fluid waves that we can detect as stimuli. Well, before we continue on with our sound perception then, let's make sure we have all of our middle ear, tympanic membrane, umbo, malleus, incus, stapes. We look at our list. We also need what's called a tympanic cavity. So this cavity here, this air-filled cavity. So the bones, the auditory ossicles are all in this air-filled cavity. We call that the tympanic cavity. So number 8. Oops, how did I mark that wrong?
The
Tympanic membrane, sorry. The eardrum, tympanic membrane should be number 6. Tympanic cavity, number 8. Sorry for that. This membrane is your eardrum, so number 6 is the tympanic membrane. 8 is the tympanic cavity. And you look at this tympanic cavity, it's important to know that it's an air-filled cavity. The bones, in order for them to move, they have to move in air. And here's a bigger difference. The air pressure in your tympanic cavity and your external auditory meatus, if those pressures are different, they're going to influence how this membrane vibrates. So when we look at this tympanic cavity, and again it's an air-filled cavity, we need to be able to keep the pressures the same on either side of the tympanic membrane. Well, the way in which we keep these pressures the same is by equilibration of that tympanic cavity, and we can equilibrate that air pressure via this tube that we call a eustachian tube or auditory tube, number 11. The function of our eustachian tube or auditory tube is to equilibrate air pressure in the tympanic cavity. Or you could say equilibrate air pressure in the middle ear. And you think, oh yeah, I've kind of experienced that. When you go up in altitude, you know, the higher altitude you are, the less pressure there is in the air. That change in pressure you can feel when the pressure inside your middle ear is not the same as the pressure outside. It feels like your tympanic membrane becomes a little more stiff and your hearing is affected. So what do you do to open up this air passageway?
Blow.
You can do a couple things. To open the eustachian tube, you can chew, you can yawn. You just need to open this. This opening goes to our nasopharynx, so the top of our throat. You just need to make that open. Some people will hold their nose and kind of blow. If you've done scuba diving, that's more a faster way to clear the air pressure. But just yawning will open it as well. Well, as soon as the pressure is the same on both sides, the eardrum can vibrate, the malleus, incus, stapes can vibrate, and then we need to know a couple other structures. Questions to that point? Okay, well if we look down here, let's make sure we're getting this path then. So our sound waves come in, they're going to vibrate the tympanic membrane. That's number 6. The tympanic membrane causes vibration of our malleus, number 12, our incus, number 13, and our stapes, number 14. The stapes, if you look at where it's going to insert, it inserts on this oval depression. Well, that oval depression, if we were to remove the stapes, we'd see that that's where the oval window is. We call this number 9, the oval window. So every time the stapes pushes or vibrates, it pushes on an oval window. This oval window is connected on the inside to fluid in the cochlea. So the function of the oval window, this is where fluid waves are created in the cochlea. So I'll just put fluid waves created in our cochlea. And you've probably heard cochlea, like to do a cochlea. Cochlea is for hearing. This is where we're going to detect that sound perception. So you go to the wave pool at Cal Expo, or you think of waves in general, even the sound waves. When a wave comes up against a solid surface, what does it do? Hits that solid surface and comes back in the opposite direction. Well, in terms of hearing, if you were to have your fluid waves go through your cochlea, get to the end, and come back, you're going to get what we call a ringing in the ears. It's called tinnitus, and you're going to feel that constant like buzz or hum or whatever it is. And we don't necessarily want that. We want the sound waves only to go in one direction. So to capture a sound wave and lessen it, or to dampen that sound wave, on the opposite side, so as that fluid wave goes around the cochlea and comes all the way back the other side, we have what's called a round window. And this round window, number 10, its function is to dampen the fluid waves. So this is where we can dampen the fluid waves. And basically it's this membrane that will allow the wave to come into the membrane, and then it slowly releases it so that you don't get reverberation of that sound wave. So it just dampens those fluid waves. Well, then for our middle ear, we only need 2 more structures, and that is, okay, here's this beautiful middle ear region. If we come back up here to see where we are, maybe you can make out a little of the oval window where that stapes articulates. But what I want to look at is this muscle. And this is one of the smallest muscles in the human body. This muscle is what we call tensor tympani, number 17. None of our models show a great view of the stapedial muscle. The stapedial muscle truly is the smallest muscle in the human body. If you look at this particular chart, let's see if I can get it to clear the zoom in. And I know this is quite zoomed in, but bear with me. You're going to see a couple dashed lines. So the first dashed line you see from this nerve kind of going up and over this way. The second dashed line you can see right here. What is that, number 26 maybe? Whatever this dashed line is. This dashed line is trying to show a muscle that's located right here and inserts to prevent movement of the stapes. So we call it the stapedial muscle. So it's just this dashed line here is representing where the stapedial muscle would be, number 16. And that stapedial muscle inserts on the incus, but it prevents movement of the stapes. And you think, ooh, well, let me go ahead and get both of those functions together, because those 2 muscles, the 2 smallest muscles in the human body, have the same function. So 16 and 17, I would put their function as the same. So if I were writing it down, the function of the stapedius and tensor tympani is to prevent auditory ossicle vibration. So those 2 muscles, their function, they're going to prevent movement of your auditory ossicles. So they prevent auditory ossicle vibration. Well, what happens if you don't let your auditory ossicles vibrate? Will you be able to hear things? No. You're like, wait, what? So these muscles stop those bones from vibrating, but the way in which we hear things is we have the sound wave come in, move the eardrum to vibrate those bones so that we can eventually hear that sound. Well, tensor tympani and stapedial muscle, they prevent auditory ossicle vibration when the noise is too loud. So when you have loud noises, it's going to prevent damage to your hearing. So they stop the auditory ossicle vibration so that you don't damage your hearing.